Hello, and welcome back to another IB Math Speedrun with me, Bits. So today we're going to be going through chapter 4.2 again. We're going to be continuing. And yeah, so let's jump right in. So in the very last question on our last speedrun, we met this function and we needed to get its gradient function, which we got as 6x plus 2. And this gradient function is normally called the derivative of the original function with respect to x. So we can say that the derivative, which we denote as f, quotation mark or dash x, f dash x is equal to the limit as h tends to 0 of f of x plus h minus f of x over h. And this is also written as dy over dx, so you might recognize it from this symbol. So if this derivative exists, we say that f has a derivative at x and it's differentiable at x, and a function is said to be differentiable everywhere if the derivative exists for all x in its domain. So yeah, that's pretty much it. And one last thing. If we are asked to find the derivative of a function from first principles, we need to use this definition, that the derivative is equal to this, and then find the derivative by letting h tend to 0. That's how we derive a function from first principles. So, on that note, we're going to be jumping into some practice problems. And I think I'll do the odd ones today. So we have first from the following functions, find the derivative from first principles and find the value of the derivative at the given x value. So we have first f of x is equal to x squared plus x minus 2. And we need to find the derivative and the value of the derivative at x equals 0. So first, let's find the derivative. We have the limit as h tends to 0 of x plus h, which is, in this case, x plus h squared plus x plus h minus 2, just substituting it into the function already, minus x squared minus x plus 2, all over h. So this will be equal to x squared plus 2xh plus h squared plus x plus h minus 2, but I'm going to ignore the minus 2 since they cancel out already, minus x squared minus x all over h. This is the limit as h tends to 0. So, if we cross these out, cross those out, then we're left with, factor h out, h times 2x plus h plus 1, all over h. And so the limit as this tends to 0 will simply be 2x plus 1. Since h over h cancels out, and this h will tend to 0, so the limit is the derivative is 2x plus 1. So that is the derivative of the equation. So we can say that f prime x is equal to 2x plus 1, and we now need to find the value of this when it's at 0, and that's simply 1. So f prime of 0 is simply equal to 1. So yeah, that one was it. Now on to the next one. So the next function is negative 2 over x, and we need to find the derivative at what? So what we have here is the limit as h tends to 0 of f of x plus h, and negative 2 over x plus h plus 2 over x over h. So we have to multiply both top and bottom by x times x plus h. So we have the limit as h tends to 0 of negative 2x plus 2x plus h all over h times x plus h. So h times x squared plus hx, effectively. And so what is this? Well, we have the limit as h tends to 0 of, we can cancel this out. So this is simply 2h, or 2 over x squared plus hx. So as h tends to 0, this will simply be equal to 2 over x squared, since hx will tend to 0. So that is the derivative of this function. So we need to find the value of the derivative at 1, so that's simply equal to 2 over 1, which is equal to 2. So the derivative will be 2 at the point 1. Okay, now on to the next one. So we have 1 over x, square root of x, and we need to find the derivative at f prime equals 9. So let's find it. Limit as h tends to 0 of 1 over the square root of x plus h minus 1 over the square root of x over h. So just like the last one, we want to multiply both top and bottom by the square root of x times square root of x plus h. So we get the limit as h tends to 0 of square root of x minus square root of x plus h all over h times square root of x times the square root of x plus h. Okay, I'm back. Sorry about that. It's being a bit silly. So the next step we want to do is rationalize the numerator. And so we need to multiply this function by x plus h over root x plus h. And so this should be able to rationalize the numerator. So this will simply be equal to x minus x minus h over h times root x plus h times root x plus h. And so we can cancel these two out, and we can also cancel these two out, so this will simply be negative. And so we have erase that, it should be negative. And so this should be the limit as h tends to 0 of negative h as negative 1 over x times x plus h times x plus h. So the thing is, this would tend, as h tends to 0, this would tend to x times 2 square root x. And so this would be equal to negative 1/2 times the root, 3 over 2 root to the x. So negative 1/2 times root 3 over 2x. So this is what this all would tend to. Yeah. Okay. So let's move on to the next one. And the next one is, oh wait, sorry, we have to actually find the value at this point first. Okay, well, sorry, I was just looking, the mark scheme has an error because it doesn't even say the answer for this question, but let's plug in 9. So we get negative 1/2 times root 3 over, it should be negative root 3 over 2, sorry, x, which is negative 1/2 times 1 over 27, which is equal to negative 1 over 54. And so that should be the correct answer. Yeah. Okay, and then that's that question done, so we now need to move to the final question. So the final question is a particle is moving in a straight line so that its position in meters in relation to its starting point is 8 plus 2t squared meters, where t is in seconds. If the particle moves through point A when t equals a, and it moves through point B when t equals a plus h, find the average velocity of the particle as it moves from A to B. Well, the average velocity of the particle as it moves from A to B would simply be the difference in y. So, sorry, this point A is when t equals a, and point B is when t is equal to a plus h. So, the average velocity as it moves from A to B would simply be a function of a plus h minus the function of it at a over the total time taken. So this would be equal to, I mean h. So this is without a limit since this is simply average velocity. So this would be equal to 8 plus 2 times a plus h squared minus 8 minus 2a squared over h. So this would simply be equal to, this is 4ah plus 2h squared over h. So, I mean, this would pretty much just be, what is this? 2h plus 4a. So yeah. And so as h tends to 0, so we need to find the instantaneous speed next, which is simply h tending to 0. And when h tends to 0, the instantaneous speed simply tends to 4a. So that will be our answer. So yeah, that was it for the speedrun. I hope you enjoyed learning about more derivatives, and I hope to see you in the next one.